typically we have a discussion about what profit is, and I found most people have a pretty good idea of what profit is. It's how much money you actually clear. It's how much money you make after you've paid off all your expenses. So it's the money you get to keep. So that's usually kind of the first place we get here. It's the money you make after expenses. So we need to put that in terms of what we've been doing. We've been talking about expenses, and we've been talking about income. We call it revenue. So to put it mathematically, it would be revenue subtracting off your expenses. So profit equals revenue minus expense. Probably not too hard to think about that or make it understandable. Just make sure that you're comfortable with the idea. Profit is revenue minus expense. Because that's going to be our new formula that's going to guide everything we do in this section. All right, for the book section, you can, of course, read through all the details. There will be some key things here to know. The first thing you're going to see graphically is kind of in the middle of the page. These first two graphs just show a couple different revenue functions. These two graphs are important. They show a revenue and an expense function. And the revenue function is the same on both of these, but the expenses are different. A lot of times, I mean, you can probably imagine common sense-wise why a company would try to cut expenses. Because if they can make the same income but cut their expenses, they make more profit. Of course, we know sometimes they cut expenses too much, the product becomes cheap, and sales go down. So it's a tightrope, but in this company, their expenses are really high. And this is a situation that you don't want to be in. There's no profit to be made. No matter the most money you can possibly make from sales will still not make up for your expenses. So that business can't succeed. That would be a business that's going to shut down. You see businesses go bankrupt, it's because they're operating this way. Their expenses have become too great, their revenue has become too small, they can't keep operating. This is a healthy business on this model. Your revenue is pretty high relative to your expenses. There's a lot of profit to be made. Of course, profit is the amount in between here. You take your expense, subtract off your revenue, that distance there, that's what's left to be made is profit. And that's what they're going to illustrate on the next page. They use these purple lines to show that graphically the distance between revenue and expense, that's your profit. So if you're just barely making more than your expenses, your profit's small. If you're making a lot more than your expense, your profit's pretty high. The next little graphic, they just put more lines on there. Now, this ties into calculus as well. It's another one of those ideas, but if you could do this algebraically, if you put enough little purple lines in here, then you can see all the possible profits. And this is kind of a new concept. You'll see this play out a whole lot. This parabola it's pretty flat at the top, and it's going to drop, but it's not going to drop fast at first, whereas the expense line's dropping evenly all the way throughout. So your maximum profit is actually a little bit higher, or the selling price anyway, is a little bit higher than your maximum revenue. A lot of people, when they do their projects, they want to sell at the maximum revenue. You want to sell at the maximum profit. You don't really care about what the maximum income is. You want to make as much as possible. So maximum revenue is right here, but generally the maximum profit is somewhere over just a little bit higher price. Not much, but a little bit. You're going to see that model play out as we go through the examples. Example 1 of the book here, this is continuing on from what we just did in the last exam, well, a couple lessons ago, but it's the same revenue and expense functions from that previous lesson about revenue and expense equations. So we've already derived these from taking our fixed and variable cost and our demand equation, putting them together, doing the same thing for revenue, and that's how we created these expense and revenue equations in terms of price. Now here's our new equation. Price is revenue minus expense. Well, it should be a pretty simple idea. You're going to do some substitution. You know what R equals, you plug it in. You know what E equals, you plug it in. Make sure you keep the minus in between them. So that's what this first step is. Substitute R and E. There's revenue, minus, there's your expense. Just be careful with your algebra here. It's not complicated, but you do have to keep track of some big numbers and some signs. So however you make this work, two negatives make a plus. And minus a plus makes a negative. So however you do your negative signs, there's a lot of little tricks for that, but the main thing is that becomes plus, this one stays negative. And then you expand everything out. And then next step is combine the like terms. So this is the only p squared term, that comes straight down. These both have p in them, so you combine them, you get 33,500. And this is a constant at the end, it just comes straight down. So it's a lot of algebra to do. It's not complicated algebra, but there's big numbers and you got to keep track of your signs. That's the two things to keep up with. And then there you go, there's your profit equation. Now, here's that equation graphed in Desmos. And I do have expense and revenue, but I'm only graphing profit right now because it's all I want to focus on. One thing I will show you here, I did put E, R, and P in for the y-axis variable. Because really for Desmos, it doesn't really care what those are. I will need to use X to make it actually show up on a graph. There's some ways around it, but it gets kind of complicated, so your best bet is to keep X for your price. But if you want to, you can keep these straight by putting E for expense, R for revenue, and P for profit on the Y variable. It doesn't confuse Desmos at all. So here's the equation. Here it is graphed. If you do it in a calculator, or if you do it in Desmos, you got to play around with the window a little bit. But it shouldn't be too bad. And here you go, here's your maximum profit, $33.50. That would be your selling price, because that's your x-axis. And this axis is your dollar amount. In this case, it's dollars of profit. You can make $323,125. Okay. Sounds pretty good, but if it's a big factory, that you've got a lot of expenses, so that may not be that great. You know, a factory is going to need to make millions to pay all the employees and machinery and all that stuff. So it's all relative to what you're doing. But it sounds like a pretty big number to us. So anyway, that's your selling price and the profits you could possibly make. The maximum profit possible. Everything goes as planned. I haven't done many of these for the examples, but I think this one's pretty important. There's just a little check your understanding things in the middle. Now, as you're going through the notes, if you want to ask me about any of these to see if you're doing it right, that's fine. Just let me know, and I can write up, do a little quick video to show you how to do it, or I can check your work, however you want to work that out. But I did put this in another slide. I just want to make sure that we do understand how this works. So they gave us a revenue and an expense equation, and we're checking to see if we understand how to get profit. So start simple. Profit is revenue minus expense. And it's just going to look more complicated because there's more pieces going in. But revenue, we've got the equation, negative 3,500 p squared plus 18,000 p minus, I'm going to color code all this stuff out a little bit here, minus your expense equation. This goes in for E, negative 1,500 p plus 199,000. Put commas in there if you want to make it look a little nicer, that's fine. The next step is really just dealing with these negatives. So let's take care of that. Negative 3,500 p squared stays the same. 18,000 stays the same. Now minus and minus becomes plus. And once I do that, I'm going to take that out of parentheses. Minus the positive stays negative. So again, however you've learned to deal with those negatives and positives, just keep on keeping on. But it's whatever's going to work best for you. And now let's condense what we can. Really, it's just these two parts right here. So negative 3,500 p squared. Put these two together, we're going to get 18,000 plus another 1,000, so 19,500 p minus 199,000. And there you go. That is your profit equation. Just make sure that you're able to combine everything the way you need to and that you are able to get that on your own. Final thing the book does in example 3 is just puts everything together. And this can get a little complicated because there's just so many things going on. But if you've been keeping up, you're just adding one more curve to it. You just add this profit equation. Everything else is what you've been looking at. So you've got your expense equation. Revenue's the bigger parabola. Profit's going to be the smaller parabola inside everything. You have your maximum revenue, your maximum profit, break-even points, and then these new zero profit points, they're kind of good for economic theory, but they're nothing we're going to really talk about in this class. So that's what those are. You can look more into them if you'd like, but we don't really need to talk more about those here. I'm going to put this back in Desmos so we can see all these pieces taking shape. So expense is the line, revenue is the big parabola, profit is the smaller parabola. So just some familiar points, your break-even points, we've already talked about those before. Your maximum revenue, we've talked about that. I really want to point out how your selling price is a little bit higher than that $30, because your maximum profit happens when you sell for $33.50. If you subtract out your expense at this price, you'll see you don't make as much profit. That's okay, it's how the math worked out. You want to go with how the math works out. So take your profit equation, graph that, ultimately there you go. That was what we were doing this whole unit. That was our goal. Find the selling price for your product, and that's it. $33.50 is what you want to sell it for, and here's the profit that you could possibly make.